last video I discussed different types of convex lens and concave lenses, and I tried to explain, with the help of refractive index. In this video I'm going to explain about the ray diagram, like we have studied in case of mirrors, but in this video we are going to study when we are using the convex lens and concave lens. So here we are starting with the convex lens. What you can see in this diagram, that this is a convex lens. Here on this side this is object, and this side this is image. F1 focal point of the lens on the object side, and F2 focal point of the lens on the image side. You can see there are three major rays here. So the center one, which is ray third, is called chief ray. So center ray, actually it starts from the point B, the object, and it passes all the way from the center of the lens to the B prime, which is the image. The first ray you can see here from point B to the lens, and from the lens it's refracted and it passed through the F2, the focal point on the image side. Second ray first passed through the focal point, then from lens, and it moves all the way to the point B prime where the image is formed. And the third ray, which is a chief ray, it passes all the way, and all these three rays intersect each other at the point B prime, here at the point B and here at the B point where the image is formed. So this is you can say it's the rule of thumb, that how you draw the rays and how it passes through the lens. This F1 is a focal point on the object side. This F2 is a focal point on the image side. So the equation, which we call the lens equation, is similar to the mirror equation. Okay, and D naught here is the distance of the object from the lens, and DI is the distance of the image from the lens. Okay, so here you can see this is for the object, this is for the image, and this is focal point. So if we know, if we know any value, we can find out the third one. If we know any two values, then we can find out third one. So now if we move to the next slide, there are some important points which are needed to discuss. This is a lens equation, okay, which we already know. This is a magnification factor, as we studied in case of mirrors. The points here, what you can see, so there are two sides of the lens. One is object side, other one is image side. Okay, so if this is your lens here, this is object side, this is image side. Second point, the positive image distance means that the image is real. Positive image distance means that the image is real. So image is formed this side, okay. If the image is formed on this side, it's real. The negative image distance on the same side of lens as object. So object side, if the image is formed on the object side here, then this image is virtual, it's not real. And this happens in case of concave lenses. Okay. And other important point, the focal length. The focal length is positive for converging lens and negative for diverging lens. So converging lens, convex lens, and diverging concave. So F is taken is positive for a convex lens, and for a concave F is negative. Okay, and this is magnification factor, height of the image, height of the object is a ratio, and it's also equal to the distance of the image over the distance of the object. So these were some points which is necessary to know if you want to calculate or if you want to apply this lens equation. In this slide, you can see the location of image if object it at infinity. Okay, so the object at infinity, so the image at the focal point of the lens. We will study different cases here, but in this case what you see, the object at infinity, okay, and the image, where we will find the image at the focal point of the lens, which is this one. Definitely, like we know already, if this is the case, and if you found the image here and here and here, so image will be inverted, okay, but at focal point. Real and inverted on the image side. Okay, this is object side. This is the first case. In the second case, what do you see here? The object beyond 2f. This is the focal length, and twice of this one from here is 2f. So if object is lying beyond 2f, this, so image will be formed between f and 2f. Okay, so like this one here. So here is your lens, here is your object, okay, and here is your f, here is 2f, similarly here is f, here is 2f, okay. So what is going to happen here? I'll try to redraw it again. So if this is your lens here, okay, this is your f, this is your 2f, okay, and the object is beyond 2f, okay. Here on this side is f, this is 2f, okay. So first thing what you will do, okay, this one here, and then you draw the G-frame passing all the way. So here you will find the image. So it's in between f and 2f. So when the object is beyond 2f, then image is formed between the f and 2f. This is the second case. Okay. Now let's move to next one. What do you see here? Third case, the object at 2f. Okay. object at 2f. If the object is at 2f, the image will be formed at 2f as well, on the other side definitely. So if this is your lens, okay, and this is your object, this is f1, this is f2f, this is and 2f. Okay, so what will happen here if it is at 2f? The object is at 2f, then the image is also supposed to be formed at 2f on the other side of the lens. Okay, so how it can happen, you can see here. Okay, and this one, so it's like this. This is the image. Okay, and definitely it will be real. It's on the image side, inverted upside down. Okay, and the same size. Now if we move to next case, which is the fourth one, what do you see here? The object is between f and 2f. Okay, then image will be formed beyond 2f here. Okay, so like if we redraw it here, okay, and this is your f, this is your 2f here, this is f, this is your 2f here, and the object is lying between f and 2f. Okay, the first ray will pass through f, okay, and then you have to see the G ray. Okay, so this is like this. So image will be formed here. It's beyond 2f. Image will be formed beyond 2f. Definitely it will be real, inverted as usual, and larger. This was the fourth case. Next one, the fifth case. So what do you see in the fifth case? That object at f focal point. Okay, if the object is at f, then you can see that image at infinity. Okay, real, inverted as usual, and much magnified. Okay, if you try, to redraw here, this is your lens here, this is your f, this is your 2f, f here, 2f. Okay, so this is object here. First thing, it should pass through f. Okay, and then you have a G frame. So it goes to infinity. Okay, and real, inverted, and much magnified. Okay, so if we put something at the focal point of a lens, on the other side, what do we get? The image at infinity, real, inverted, and much magnified. So these were few cases we discussed, which is related to the convex lens. Now let's move to the next one. In this case, what we are going to study, this case is a bit different than the previous 5 cases. And what do you see here? If the object between the F and C, see the center of the lens, and F is a focal point, so the object is here. So what will happen in this case, the image will never form on the image side. Okay, so these lines are never gonna intersect. So the image will be formed on the object side, as you can see here. Okay, if we extend these rays on the object side, so image will be here beyond 2f, and this image will not be real, definitely it's a virtual image. Okay, and erect and magnified, it's not inverted. Okay, so if we draw it, so if this is your lens here, this is your F, this is your 2f, sorry, 2f, and this is C, F, 2f. So if the object here, this is object, okay, and as usual it should pass through F here, and the chief ray will pass through here. So these two rays will never intersect on the image side. Okay, so we have to extend like this on the object side, and we can say they are intersecting at certain point where the image will be formed. So not the real image, it's a virtual image, it's erect, it's behind the object, and it's magnified. So that is why this case is different as compared to the other 5 we have discussed, that the image is formed always on the image side, but here the image is formed on the object side. And this image is not real, definitely it's a virtual image. Okay, and it's formed beyond 2f on the object side. So whenever we design any optical system, we have to consider all these cases. We design, whether we design the telescope or microscope or some complex optical systems. So this is all actually what we discuss about the convex lens here. And in my next video we'll discuss about the concave lens and image formation and their rays. So I hope you enjoyed this video and try to understand, and see you on the next video.